So you've got to look at the before collision and the after collision. So before collision, we got 600 gram or 0.6 kilogram cart, and we got another cart moving towards it, also 0.6. And it's moving with a velocity 3.2. Did anyone draw a picture like this? Okay, so the sum of the momentum are the mass of the first cart times its velocity plus the mass of the second cart times its velocity. So the total momentum 1.92. So what do we know about momentum before and after a collision? It's conserved. So the momentum before is going to equal the momentum afterwards. So we know the total momentum is this, which is equal to, the carts are now together, they're friends, they're hugging, and they're traveling at some velocity together. We know their combined mass is what? 1.2 kilograms. We don't know the velocity. So we do 1.92 divided by their combined mass to get the velocity. So their combined velocity after the collision is 1.6 meters per second. Okay, any questions? Today we're looking at kinetic energy and elastic and inelastic collisions. So you guys remember kinetic energy and the formula? Kinetic energy is scalar, in case you forgot, it's in joules and it's got this formula. M is mass in kilograms, very important. V is velocity in meters per second. So some of you forgot to convert to meters per second. So write yourself a note. If it's in kilometers per hour, what do we do? Divide by 3.6 to convert it to meters per second. So we have velocity of a cricket ball, which weighs 0.163 kilograms, and it has kinetic energy or movement energy of 141 joules. So we've got this formula, sub everything in. It's in joules, we don't need to convert it. It's in kilograms, and we don't know V. Bring the half over and divide by that, and then square root both sides. Did you get the same answer as me? Check on your calculator that you know how to use a calculator. Okay, so kinetic energy is similar to momentum. So you can sum the kinetic energy at the start, so before, and you can sum the kinetic energy after the first cart plus the second cart, like that. And this one equals what happened to the carts after. They were joined, yes. So now the mass is what? 1.2. And what was the velocity we found? Okay, so put it into your calculator. You tell me what happened. Energy was lost to the system. So was momentum conserved? Momentum, was it conserved? Yes, momentum's conserved. Is energy conserved? So we should make a comparison. The energy afterwards is less. Energy has been lost. So some notes. Elastic collision. Momentum is always conserved in a closed system. Kinetic energy is sometimes conserved in a closed system. What type of energy could it have transformed into? sound, heat. Oh yeah, maybe like light if there was like an explosion of some sort. If kinetic energy is conserved in a collision, it is called elastic collision. So if it is conserved, it's elastic. If it's not conserved, it's called inelastic. Okay, so for the first one, you've got two carts and they join together. So what type of, is it elastic or inelastic? Collisions where two objects join together cannot be elastic. What happened to the energy? It was lost, so it's not elastic. So the first example is not elastic or inelastic because it is a collision that joined together and kinetic energy was lost or was transformed to heat or sound or light.